A good part of the discussion in section 13.2 of the book concerns stepwise regression. Stepwise regression is of two types: forward inclusion or backward elimination. Forward inclusion begins with the single predictor variable, which accounts for the largest proportion of the variance in a particular dependent variable, and includes additional variables as long as those variables contribute a statistically significant amount to the prediction of the dependent variable. In this video, we're going to look at the development of the data necessary to begin the forward inclusion method using Excel. Here we have data from the State of the World's Children 1996. As the book points out, the State of the World's Children is published every year, and so there is other data available, but again, as the book points out, this particular data set shows some interesting characteristics relative to forward inclusion and backward elimination. There are 75 countries of the world included in the data set, and the variables for these countries include the proportion of households with safe water, with modern sanitary facilities, with access to health services, the proportion of children 1 year of age immunized with DPT, the contraceptive prevalence rate, the log of GNP, because the actual value of GNP is not linearly related to the dependent variable, female literacy, the total fertility rate, and under 5 mortality. Under 5 mortality is the dependent variable. So we are going to go through the process of determining which variable should enter first into a forward inclusion analysis of these data. In order to do that, we're going to use Tools, Data Analysis. We're going to select Regression. When I say OK, the dependent variable range will be under 5 mortality. Control Shift down arrow selects the entire variable. The X input range will always be one of the independent variables, and we'll begin with safe water. Again, Control Shift down arrow. There are labels in the first row, and now we are going to put the output in M1. And when I say OK, we get the information that safe water by itself, there's the variable and its coefficient, accounts for 43% of the variance in under 5 mortality. Now we're going to take the next step of seeing what proportion of the variance in under 5 mortality is accounted for by the availability of modern sanitation. So we'll go to Tools, Data Analysis, Regression. The dependent variable remains the same. The independent variable now changes to column D, Control Shift down arrow, and we will change the output range to M21. When I say OK, we find that 56% of the variance in under 5 mortality is accounted for by the availability of sanitation, and there is its coefficient. We proceed in the same way through the variables health services, DPT, CPR, log GNP, and now we're up to female literacy, Control Shift down arrow, and female literacy will go in this cell, M121. We'll say OK, and we get the results for female literacy. We're accounting for 55% of the variance, and there's the coefficient. And now we'll get the last one of the independent variables with data analysis. Under 5 mortality is still the dependent variable. The X input range now becomes total fertility. This is Control Shift down arrow, and the output range will be in M141. And when I say OK here, we get the final output. Now we have in column N all of the R-squares relative to the relationship between the independent variables and the dependent variable under 5 mortality. Total fertility accounts for 67% of the variance. Moving up, we see that female literacy accounts for 56% of the variance. Log GNP accounts for 54% of the variance. CPR accounts for almost 72% of the variance. DPT accounts for 49% of the variance. Health services accounts for 43% of the variance. Sanitation accounts for 56% of the variance. And safe water accounts for 43% of the variance. So if we were to develop a forward inclusion multiple regression model, we would begin our analysis with CPR as that variable that accounts for the largest proportion of under 5 mortality. And we could arrange the data we have developed here to give exactly the information shown in figure 13.15.